Hello, my name is Cynthia Hebein, and I am part of team number 16. Our team name is Donda, and I will be covering our team's project of a swarm of grocery store helper robots. The team was inspired by the events of the past 2 years in regards to the pandemic, specifically with the ramifications it has had on essential businesses like our grocery stores. Our problem statement reads as follows. Grocery stores need a way to continue normal business operations while employees are absent because it is detrimental to the local community to have an essential business provide inadequate services. The team's robot swarm aims to fulfill basic roles of grocery staff in the case of manpower shortfalls. It cannot be stressed enough that these bots are not meant to replace human workers entirely. They perform rudimentary tasks that are meant to serve as a stopgap solution to a lack of manpower. Let's move on to meeting the swarm. We have a warehouse bot and a stalker bot, a checkout bot, and a clean bot. This presentation will focus on the design for the clean bot. This is the Tinkercad design for CleanBot. CleanBot's front features a debris drawer with handle that can be removed for emptying trash and an ultrasonic distance sensor for detecting messes and obstacles. The back of the bot has a removable panel for accessing the bot's wiring and components. The bottom of the bot houses the vacuum chute with brush rollers that empties into the debris drawer and a mop pad that cleans up liquid messes from the floor. Finally, the top of the bot has a solar cell to power the bot and mounted electromagnets used to collect and move shopping carts. Internally, CleanBot has an infrared sensor that allows it to receive signals from the central hub or other bots in the swarm to clean messes at signaled locations or to put away carts on demand. The total size of CleanBot is about 2 by 2 cubic feet. The internal circuit design is shown here. A solar cell, an ultrasonic distance sensor, and IR sensor are wired to the Arduino board directly, as well as 2 hobby gear motors for the vacuum brush rollers. 4 more hobby gear motors are wired to an H-bridge motor driver to control the bot's wheels. The only component not wired here are the electromagnets for cart collection, as Tinkercad lacks them. The activity diagram shows the logic flow of the CleanBot and its Arduino code. The bot will begin a sweep on a preset path, essentially constantly vacuuming and mopping. If the bot receives a mess signal through its IR sensor, it will go to the signaled location and clean the mess or put away the cart. It will then resume its sweep. The estimated cost of building CleanBot is about $126.50. This is optimal as building the bot will cost about as much as the pay for a worker in an 8-hour workday. Here is the demonstration of CleanBot's system in Tinkercad. Here is the IR sensor that will receive signals from the Swarm-In hub to go to messes or carts, the solar cell, the ultrasonic distance sensor, and the hobby gear motors for the bot's wheels and vacuum rollers. Again, the only component not shown or coded here are the electromagnets used during shopping cart collection. And when we run the code, we can see that it works successfully. All of the gear motors are running as expected. In summary, the swarm will cover manning shortfalls in a grocery setting, and CleanBot is designed to sweep for debris on a set path as well as respond to calls to clean up messes at locations signaled by the swarm in the central hub.